the resultant force of the two forces acting on cable AB and cable AC. I have presented the procedure for you guys in this left column. To find the resultant force, first we need to write each force on its Cartesian format, and to do so, first we have to write the vector that each force is acting on that vector in Cartesian format. That being said, we have to write first the position vector for AB and position vector for AC. Let's start with A. Very quickly, you need to write the coordinates for point A, which are 0, 4, and 3, and coordinates for B, which are 1.5, 0, and 6. From here, you need to plug in to this equation to find RAB in Cartesian. Don't forget, this red color means that it's a vector, it's in Cartesian. And this solving, I'm putting an arrow on top of it to show that it's a vector. So it's going to be xb minus xa, that's 1.5 minus 0, so it's 1.5 I. 0 minus 4, that's negative 4 j. 6 minus 3, that's plus 2 k. Okay, now I can find the magnitude of RAB, which I should use this square root of square. That's 1.5 square plus negative 4 square plus 2 square. And so I need to extend all the way to here, and if you solve it, that's going to be 5.2 meter. The same process for AC. So I write again in here so that I don't make mistake. The coordinates for A was 0, 4, and 3. And the coordinates for C are negative 2, 0, and 4. Let me draw a line in here. Now, RAC, again, the vector or the Cartesian format, is going to be negative 2 minus 0 is negative 2i. 0 minus 4 is negative 4j. And 4 minus 3 is 1, which I don't write it, just k. And similarly, the magnitude of RAC is going to be square root of squares. Negative 2 square, negative 4 square, and 1 square. And again, extend this to here. And if you solve this, you will get 4.6 meter. Now, I have solved step 1 and step 2 of this procedure. Step 3, which is this guy in here, it says that find UAB. UAB is RAB, this Cartesian format, divided to the magnitude of RAB. Again, I will use this arrow to show it. So UAB is equal to RAB, which is 1.5 I negative 4j plus 2k divided to 5.2 meter. And if you solve it, it's going to be, you can leave it as it is and multiply it to the force, or you can just divide each individual of these guys to 5.2. So it's going to be, I will round it up a little bit. So 29 I negative 0.77 j plus 0.58 k. The first one also was 0.29. So this is my UAB, and the same process for UAC. So UAC is equal negative 2I, negative 4j, and 1k divided to 4.6. Again, UAC is going to be, you divide it, it's going to be negative 0.43 I, negative 0.87 j, and plus 1.22K. So this is my UAC. Now, step 3 also is done. Now I need to find each force in Cartesian by just multiplying the given magnitude to this vector that I determined. Now, FAB is going to be 55 times negative 0.29I, negative 0.77J, and 0.58K. You multiply it, you will get something like, again, if you rounded it up, 15.95I, negative 42.35J, and plus 31.9K. This is our FAB in Cartesian, and the same for FAC, and that's going to be 40 times this vector in here. So 40 times 0.43, negative 43, I, negative 0.87J, and plus 0.22K. Again, you multiply it, FAC is going to be equal negative 17.2I, negative 34.8J, and plus 8.8K. So I have FAB now in Cartesian, and I have FAC in Cartesian. Clearly, I can add these two guys to each other to find FR. FR is FAC plus FAB plus FAC. So X components 15.95 minus 17.2, that's going to be negative 1.25I. Negative 42.35, negative 34.8, that's going to be negative 17.15J. And plus 31.9 plus 8.8, that's going to be equal to plus 40.7K. This is FR in Cartesian. And if you want to find the magnitude of it, again, you will use this square root of squares. We have repeated this many times. You know how to do it. Plus negative 17.15 square plus 40.7 square, and if you solve it, you will get around like 87.2 Newton, the magnitude of the resultant force.